Welcome to a special episode of Doug's Electronic Repair Bench.
Good afternoon, YouTube. Welcome to the second episode of the Troubleshooting series. What I want to do today is discuss a few things. Mainly what type of radio this is that we're going to be troubleshooting. You've all heard of the All-American 5 radio. Well, this is the same radio but with an added stage, and it's commonly known as the All-American 6 radio. Whenever additional stages are added to the original design, that's what they usually call the results. And this particular version adds a RF amplifier to the mix, and that can be seen in the diagram. There's really not a lot of difference. The only difference is that instead of 5 tubes or 6, all the other parts that make up an All-American 5 are there. It runs off of AC line. It's AC DC. So there's no transformer. So if you add up all the tubes, you'll notice that the result is around 120 volts, somewhere around in that area. So that's where the how the tubes get their power directly from the line, and the line is also rectified and used for B+ too in the power supply. So anyway, that's how that works. Alright, next we're going to look at the radio in particular that we're working on, and whether it's early or late production run, and what makes it early or late. And if we look at the first illustration, we can see there's an image of the early and late versions of the schematic. This is the part that has the changes in it, so we'll be able to document all the changes from this one illustration. So if we look at the upper left hand corner there, we see a orange box, and that's around the old version. You can see there's a coil and a resistor there, and if you swing over to the late version image, you see the arrows pointing. There's nothing there, so that has been eliminated, and so that would be the number of first change. So on this next image, we'll see another orange box on the early version, and look at the late version. Again, you'll see that is gone, so that would be change number 2. This third image is the same way. There'll be an orange box, and if you look at the late side, you see it's gone. So that would be change number 3. The last image shows a different kind of change. There's nothing on the early version, and then if you look at the late version, there's a capacitor and a resistor added there. So that would be all of the changes that show the differences between the early and late version. And what I've seen so far, we have the late version here, and if I run into difference on the way here, we'll note that as we go, but for now that's about it. Alright, the next thing we're going to look at is the different stages of the radio. The illustration above separates the various stages in colors, and all the colors are listed as what they are on the left there. You have the RF section, the oscillator converter, and then you have the IF, and then you have the detection, and along with the first audio stage, and then the audio output, and lastly you have the power supply. It's pretty simple the way it's broke down. You can see those are not absolute dividing lines or anything like that, but they pretty much give you an indication of what all is contained in the each section. And we're going to look at the signal path now in a second here, and you'll be able to see it in a little bit more detail. Okay, the first section we're going to look at is the RF section, and as you can see, we have radio signals coming into the antenna or to the loop antenna, whichever is present. And for our purposes, this is going to be a 900 kilohertz signal, and that's what the tuner would be tuned to. So as you can see, the signal path comes in through the antenna, it goes through the tune capacitor circuit and into the grid of the RF amplifier, where it is amplified and then sent on its merry way through the plate and through the coupling capacitor there. And that's pretty much all there is to this is a pretty simple circuit on this amplifier circuit. So we'll go on to the next one now. Alright, this next stage is the oscillator converter. I like to refer to it as a mixer because that's basically what it does. As you can see, the signal is traveling out of the plate of the RF amplifier through a coupling capacitor into the grid of the oscillator converter. At the same time, if you look at the oscillator, which is running, it's providing a signal on its own, and for our purposes we're going to run it above the signal that's coming in. It'll be a 1355 kilohertz signal being applied to the other grid, where they are mixed in the tube, and the result is that we get out the original 900 kilohertz signal, and we get out a oscillator signal, which is 1355, and then we get, if you look on the other side there, that's a combination of the two signals that are being beat together, and also the difference of the two signals. So that's what we have, all four signals coming out of that tube, and what the next stage will do is discriminate that to a 455 kilohertz signal. This is what we want for their IF, and reject all the other signals. Okay, as I said, this next stage is the IF, and basically it's just a tuned transformer there to that's tuned to 455 kilohertz. It passes that signal and takes it to the IF tube, which goes into the grid. It's amplified, it passes out through the plate, and it goes to the next second transformer, the IF transformer. Again, it's refined, tuned, whatever you want to call it, and passed along its way. Alright, we've gone through the second IF transformer there. We go into the detector, which is basically a set of diodes there that rectify, and I hate to use that term because it's really demodulating the signal is what it's doing. And it does that with the diode sections there, and it's passed along through the, if you trace the signal going down through the cathode there, it goes around and comes through the volume control and passed along through the capacitor there and goes back up to the grid of the detector, where it's amplified. That's the first audio amplifier of the detector of the stage there, and it's passed along there. It's now at this point it's audio. You see the colors change to yellow there from the black, and that's what we're amplifying now is the audio signal. It goes out the plate of the detector audio tube, and it's passed along through the coupling capacitor there to the next stage. Alright, this next stage here is the audio output, and again we're taking the output from the first audio amplifier and pass it along through the coupling capacitor. As you see, watch the signal there. It goes into the grid of the audio output tube, where it is amplified and passed along through the, if you follow it down through the speaker audio, I'll get it right here in a minute. The audio transformer, where it is matched to the lower impedance speaker, and the output comes out the speaker. And that's pretty much all there is to that. Alright, that's about all I have time for this time. So next time we'll get into the specifics of troubleshooting and how to do it and the methods used and things like that. So thanks for watching.